Today we're going to study the eddy current. Eddy currents. Now, if we take a slab of metal, this is some slab of metal, okay? Like iron or copper. And let's see, it has some handle. This is some handle where you put your hand here, okay? And then you pull here with certain velocity, V. And this slab of metal is in a region of magnetic field. Let's see, we have some magnetic field in this region here. Okay, and let's take the magnetic field to be going in. Is going onto the paper. Here is the B field. So this magnetic field, this is a slab of metal here. This, maybe I use different color. This is the slab of metal. Okay. And this metal is metals are conductors. So this metal is a conductor, and no, it's not attached to any current or anything. It's just free, just a slab of metal that you take from somewhere and you put it in this magnetic field, and magnetic field is going in. Now we're gonna pull this slab out, so put some force like that. What's gonna happen? Remember, this is a conductor, so there is a magnetic field. So since it's a conductor, what's going to happen is this metal is like it has a bunch of wires put together. Like you have one loop here, one loop here, one loop next to the other loop. It's like this. See, you have another loop here, another loop. It's like you have a bunch of loops like that. And whatever happens to one loop will happen to the other. So when you pull this slab of metal, you are decreasing the flux in this region here. This region here, you're decreasing the flux. So what's going to happen? You're going to generate, we go to Faraday's law. E is equal, I just use magnitude. We put here d phi over dt. This is magnitude. So these change in flux will create a voltage, and this voltage here will create a current. So you will have some current. You will have some current that's gonna go something like this. It's gonna the electrons, they're gonna swirl around or swirl about. So we need to know the direction of this current that we're going to be generating, or we generated by pulling the slab in the magnetic field. So we go to Lenz's law, and Lenz's law says that as we pull the slab, we're decreasing the flux. So the current is going to go in a way to increase, to compensate with that decrease of flux that we're losing. So if I have the current coming down here and going up here, this current here will generate a magnetic field B prime that's going in. You see, this blue magnetic field is B, is going in. Now when we move this slab to the right, we are actually decreasing the flux. So a change in flux will create a voltage, which will create a current. So what we'll have a current. So the electrons actually will go, the electrons will go counterclockwise like this, and the current will go clockwise like that. So this loop here of current, remember it's not just one loop, you have a bunch of them inside here. So you have all these electrons going around, or this current going clockwise like this. And that current will generate a magnetic field that's going into the page. So when this current moves in the slab, it will heat it up. So this slab will be warm because you have this motion of electrons in it. So this current that's swirling about is called the eddy current. Okay? So if we take some again, some slab of metal like this is a slab of metal. Okay, and then you have some pivot here. This is a pivot. So, and then you have some magnetic field in this region here. Okay, this is some B field. So when this slab of metal swings down in the magnetic field, you will have a current, and that current will generate a B field going in. Like I did here, we have a B field that's going in because we're losing the magnetic field, or we're losing the flux. So this current, actually, you will feel when you pull this slab of metal, you're gonna feel like some force is trying to pull you back. You will feel some hesitation, okay? This is beside the weight or the inertia of the metal. You have some force coming from this current in the magnetic field. So you feel like you try, it's not easy to pull this slab. So the same thing here. So when this slab swings in the magnetic field, you're gonna generate a current, okay, in this region. And then it goes past, come back again, you have another current. So the thing keeps swinging back and forth. But because of this hesitation, you see, there is this force that pushing against you when you try to go in, when you try to leave it, pull you back. So it will slow down this oscillation. So this slab of metal will finally stop, and then it will be warm. So before you start swinging, before these slabs start swinging, they'll be like at room temperature. And then you make it swing for a while in this magnetic field. And then this electron will start going around, swirling about in the metal. Whenever the thing goes past the magnetic field. And then after a while, this metal will be warm. So this eddy current, a person has to be, or an engineer or a scientist, has to be aware of it. And it can cause some problems if you have some sensitive equipment, very sensitive, and then you move those equipment in the magnetic field, is going to generate these kind of eddy current, and that current can interfere with the signal that you have in your equipment. Okay?